Hey, welcome back. Now at this point you should be familiar with pointers to pointers, arrays of pointers, and also how we can create dynamic arrays as I explained in the lecture on dynamic memory allocation for an array in the pointers and references lesson. Now this lecture is about how we can create a dynamic two-dimensional array using raw pointers and then also allocating using the new operator. And then of course we also have to keep the allocation in mind using the delete operator. Now dynamic two-dimensional arrays can be a bit confusing to beginners, so I'll build up to the topic using a few simple examples and illustrations, and by the end of the lecture you should have an understanding of how dynamic two-dimensional arrays work and why we need to use a pointer to reference that dynamic two-dimensional array. Okay, so we'll start off with a recap on this dynamic memory allocation for an array that we discussed in the lesson on pointers and references. As a recap, we can have a dynamic array, and the benefits of that here is that it can be allocated, or in other words, its size can be determined at runtime. The size of a stack array needs to be determined at compile time. We use the new operator followed by some type. In the example we have the int as an example. We specify the array size. You can pass that in, enter it maybe from the keyboard at runtime, as we have demonstrated before. Now that will allocate an object for the array on the heap, and it's going to return the address of the first element of the array object, which we can assign to a pointer. We need to keep in mind that the new and the delete operators go hand in hand, so if you have the one, you will have the other at some point. If you allocate an object on the heap, then we need to delete it later on. So we do delete, and because it's an array on the heap, we need to follow the delete operator by the subscript operator, followed by the name of the pointer, in this case some pointer name. With this, if we read this from left to right, we are going to delete, or in other words, we are going to allocate some array pointed at by some pointer identifier. Okay, so in this example we have some array pointer, a pointer to an integer which is going to store the address of what exactly? Well, it's going to store the first element of the array object. Okay, we do new int, and we pass in a size for that, the number of elements that we want that dynamic array to have, the amount of integers that that array will have, right? So the array pointer is going to hold an address of what? It's going to hold the address of the first element in the array object that is on the heap, and that is a variable. So the pointer is basically a pointer to a variable, right? It is not a pointer to a pointer, it is simply a pointer to a variable. The array is basically a contiguous block of memory in the heap in this example. You can think of it as a bunch of integers, in this case 5 integers, right next to each other in memory. And as we discussed, we can also apply the subscript operator on that pointer, array pointer. This allows us to use that array, which is on the heap now actually, like an ordinary array. Instead of having to do pointer arithmetic or anything like that, we can simply use the subscript operator. A simple illustration on this, we have a pointer to a heap array called ptr, so that's a pointer to an int, and we allocate a new integer array on the heap with 3 elements. We use list initialization to initialize those elements to 3, 5, and 9. When we allocate the array on the heap, that is going to return the address of the first element in the array, which will get assigned to or stored in the pointer ptr. Then as I mentioned, we can use the subscript operator on the ptr pointer to access the integers within the array on the heap. And of course later on we also need to use the delete operator to allocate that heap array. I prefer to use a generalized entity class for my tests. So I have this entity class with a constructor, and unlike the fundamental types, this is actually going to do a console output statement when it gets destroyed. Okay, so that is what is handy with the entity class that we have here. I typically use something like this for my tests. Okay, so I used this entity class in my previous examples. It has a formal parameter member p with a default argument of 0, and it's going to initialize the member by assigning member p to that member. Member again is an integer in the private section. The constructor is also going to do this console output statement entity constructor invoked the member ears and member. You don't necessarily have to do this printout. Sometimes I don't do that just because it can clutter up the console output window with all of those printouts. Then the destructor is going to print out something similar, entity destruct invoked, and the member was as well, because of course during program execution we can go and modify the state of the instance. Then I have a toString function which is simply going to print out the member. You can print out the member ears member if you want, or something like that. And then I also have a setMember function. Now in the main, so instead of doing a pointer to int, I have a pointer, array pointer, which is a pointer to entity in this example. I also have the constant integer size again, and then I allocate using new. I allocate an entity array on the heap, pass in size. Okay, so I have the subscript operator and I pass in the size. And then I use the list initialization and I do constructions here. Entity I pass in 3 here for as an argument for the constructor, and then 5, and then 9. And then I simply use a for loop to invoke the toString function of each one of those elements in the array on the heap. Then since the array is on the heap, we use the new operator, right? That is also followed at some point with the delete operator. So we have to deallocate whatever the array pointer is pointing at, we deallocate that heap array, and then we set the array pointer to null pointer again. Again, the benefit of this generalized entity class here is that we can now see if this actually works. So I can build around this, and we get entity construct invoked 3 times. Member is 3, 5, and 9 for each one of those. Then we do the toString for each element in the array using the for loop and the subscript operator on the array pointer. So we get 3, 5, and 9. And when we invoke here where we use the delete operator, okay, where we go and deallocate that array on the heap, it will deallocate all of the entities that is in the array on the heap. Okay, so we get entity destruct invoked, the member was 9, 5, and 3 again. Okay, so just trying to reiterate why we use this generalized entity class with the constructor and destructor, and then also how we allocate a heap array, and then also how we deallocate that heap array. At this point, you should also be familiar with creating arrays of pointers. So in this example, I have an array of pointers, pointer array, and I have this assignment list initialization where I pass in the address of x, y, and z, which is declared right here and initialized right here. This is from a previous example, so we do a for loop where I simply go and print those elements out. I can build around that and we should get 3, 5, and 9 printed out. Now in this example, the pointer array and whatever the pointer elements reference, in this case these variables here, x, y, and z, those variables and the pointer array itself is all on the stack. So in the next subsection, we'll do a bit of an exercise and we'll discuss how we can have an array of pointers on the stack and have its elements reference. In other words, point to objects that are on the heap. Now, how would this work with user-defined types, such as the entity class again? And as an exercise, as a sort of warm-up for some of the upcoming subsections, I'd like you to try and write an array of pointers to dynamic heap objects, but in this case we'll have a pointer to an entity, some user-defined class or struct. It doesn't have to be the generalized entity class, it can be something else like players or whatever you want. I have an illustration of how this would work. On the stack we have an array of pointers. Each element in the array is a pointer which will store an address of some heap allocated object. And for the exercise, you can decide how you want to allocate those heap objects. You can do it in a loop, for example. That's how I'm gonna do it. I'll actually just pass in the iterator in the for loop to the constructor for the initialization. The tricky part will come in with the deallocation of those heap objects, and we'll really test whether you understand what is going on with that. As an example, if I build around my program, I get some allocation section. You can decide how you want to do the printouts. I get entity construct invoked, member is 0, 1, and 2. That's because I do that in a for loop. I just pass in the iterator I for the argument for the construction. Then I have this section right here, entity toString. I'm not using a static function, I'm just doing the qualification here to show that I'm invoking the toString function of the entity class, followed by the allocation of those entities on the heap. So we get the entity toString member function printout, so we get 0, followed by the allocation, so we get entity destruct invoked, member was 0, then we get 1 printed out, destruct invoked, member was 1, and so forth. Finally, we get the end of the program. So with this exercise, you have to do allocation and also think about how you're going to do the allocation of those heap objects. Again, on this stack, we have an array of pointers to entities, but the actual entity objects are allocated on the heap. And of course, the addresses of those entities on the heap are stored within the array of pointers. So give this exercise a go. Again, your output does not have to look exactly like this. This is just to get you thinking about what is going on and to basically warm you up for the upcoming subsections. Okay, let's look at my solution. I'm using the class entity again. Now in the main function, I'm still using the constant integer size. And then I go and create the pointer array, which is an array of pointers to entities. And I pass in size between the brackets. And then I use the list initialization, empty list initialization here. Then for some separation in the console output, I do this printout console output allocation. And then I have a for loop. Int I is equal to 0, I is less than size. And for each iteration, I get the pointer array. I pass in I in the subscript operator. For example, in the first iteration, this is going to be 0. So we pass in 0, we get the first element. And then I assign this new entity I to that. We'll pass in 0 for the argument, which will initialize the member of the entity here. to 0 as well, okay, in the constructor. And of course, we also get this printout in the constructor as well. Then next I want to think about how I'm going to do the allocation, and I'm going to do that in a for loop as well. And before I do that, I'm going to do the entity toString, so I have a console output string that is going to indicate what the output is going to be. Do pointer array I toString. Of course you don't have to do this, but I did it in anyway, just to remind you how we would go about invoking a member function on an object that is now actually on the heap, but that is pointed at by an element which is now in a pointer array. Instead of doing the referencing on this here, and then doing dot and then toString, we simply use the arrow member accessor. Then the next statement is really where the challenge sort of comes in here, and that relates to how we can go and deallocate those elements on the heap. Hopefully you managed to do this by yourself. Basically what we need to do is we need to go and delete, or in other words deallocate some object, right? How do we specify exactly what object we want to deallocate on the heap? Well, we use a pointer. I use the subscript operator on the pointer array, okay, and I pass in I. For example, in the first iteration of this for loop, we are going to pass in 0 again. In that case, we fetch the first element in the pointer array, which is a pointer which stores an address. Then of course we apply the delete operator on that pointer, and in that way we are going to deallocate whatever that particular pointer is pointing at. Then we set that pointer to null pointer as well. That element in the array will now store a null pointer instead of some address. Then we go around again and we do 1. Okay, so we do toString on the object that is on the heap, which is referenced by the second pointer element within the pointer array. We return that pointer and then we deallocate whatever that is pointing at, and so on. If I build around this, we get the output that we had before. We get the constructors in the allocation section, and in the section here where we do entity toString followed by the allocation, we get 0 printed out with the toString member function invocation, and then we get the destructor as well. As demonstrated in the previous examples, we can have an array on the heap, and then also demonstrated that we can have an array on the stack, a pointer array on the stack that stores the addresses of heap objects. You may have thought about this already, but if you put these together, then of course we can have an array of pointers on the stack, and we can then store arrays on the heap and store the address where those arrays start, so the first element in those arrays, in the pointers in the array that is on the stack. On a high level, this is what it will look like in memory. I've simplified the addresses a bit, and we can see that we have those pointers in the array of pointers on the stack. Those store the addresses of the heap arrays, where those heap arrays start. In this example, we are simply using integers. In this example, I'm going to use the generalized entity class again for the example so that we can see the destructors get invoked. Instead of using an integer, and in the main function I have the constant array size. In this case I'll just have 2 elements, and then I'm going to go and create an array of pointers to entity, pass in array size for that. Then instead of allocating entities for each element in the array, which of course we can do, I'm going to do this here. Instead, I'm going to allocate a new array on the heap and store that. So basically the address of where the heap array begins, we store in the first element, and then in the second element we store a different array. Now as you can see here, we actually have different sizes of arrays. This first one I have 2 elements, okay, in that array. And then here for the second element in the pointer array, we actually have 3 elements allocated in a heap array. And I use the empty list initialization for that, so it's going to allocate 3 entities in that heap array, and it's going to use the default constructor where I have a default argument of 0 for the member. And for element 0 I actually have these 2 explicit constructions where I pass in 3 for the constructor of an entity there and 5 for the construction of this entity here for the second element in that array. You might be thinking, how can we access or change those elements which are now on the array in the heap? Well, we can use multiple subscript notation here. So we have the pointer array name. We've seen that we can use the subscript with a pointer before, but we can have 2 subscripts as well. Basically the subscript expressions are going to evaluate from left to right. The first one is going to get evaluated, and that is basically going to return a pointer again, or a pointer expression. Then we take that pointer expression and we apply the subscript operator to that. Following the evaluation of the final subscript expression, we apply the indirection operator. Based on that, this is going to return an L value, and then we do dot set member on that. In this expression, we are targeting the second element in the pointer array and the third element in the array, which is actually now allocated on the heap right here, which will be initialized to null. The member is going to be initialized to null because it's going to use the default constructor, and so I set the member on that to 55 here. Okay, we've discussed the allocation, and of course we also have to do the allocation. For every element in that array, we have I is less than array size here. We start at 0. We have to go and deallocate. What exactly will we deallocate? An array some array which will be returned or pointed at by some pointer, which this will return. Point array again is an array of pointers, right? So this is going to return, this expression with the subscript is going to return a pointer, and that pointer is going to point to an array because that is how we have initialized that. Of course, you can have one of those point to a particular entity instead of an array, but we typically don't do it in that way. You typically have either arrays on the heap or entities, but not both, because otherwise, of course, that is going to complicate your deallocation process. And then also make sure to set that to null pointer. Let's go and build around that. And we see we get a bunch of constructors invoked. We get those two constructors invoked, which is allocated right here on the array, on the heap right here. We pass in 2, so those are 2 elements, and 3 right here, so we have 5 in total. 5 constructors right here, and then we also get 5 destructors invoked. We can see that we have changed this one with the member 55. We have changed during program execution, and the other 2 will remain 0 as well. Just out of interest, I want to show you that you can actually go and mix the allocation in this pointer array of allocating arrays. So mixing the allocation of heap arrays and heap objects by themselves, heap variables, that again are not arrays. The first element in the pointer array now stores an array of entities with 2 elements, and the second element in the pointer array, which is a pointer, is going to store this particular entity on the heap, an entity with a member that stores 22. We need to make sure to deallocate that properly now. That is not going to be an array, so I'm simply going to call delete on whatever this right here returns, which will be a pointer. Then before we build, we need to make sure to comment this line out here, so that we do not try and set something that we cannot set. Build around now, that should work fine. And we can see that works fine. We have 3 elements on the heap now. 2 of those is in an array on the heap, and 1 is an object by itself. And those get destroyed properly. We get end of program. We don't get a crash or any weird behavior here. So this works fine, it should work fine. But again, this is typically not what we would do. We would typically have an array of pointers, which we will either use for objects or for allocating arrays on the heap, but not both, okay? The size of the stack array needs to be defined and known at compile time. But of course with heap arrays, we can allocate those heap arrays during runtime. For example, let's say we have an array of players. Let's say we have 3 players here, and we are keeping track of the amount of times that that player has played a particular game, and also their high scores. Player 1, for example, has played the game 3 times, right? So we allocate a heap array with 3 elements, and we store the player scores for each time we play the game in that array. 3, 6, and 9, for example here. The third player only played the game twice, so we store the score for that player in a heap allocated array. Now let's say one of those players come back and play the game again, then we can call some function which can allocate a new heap array, storing all of these scores that the player had previously, but also storing the new score from the latest play session. This is just a high level silly example, but you get the idea. What's nice about this is that we can have these heap arrays allocated at runtime, right? Now you might be thinking, wait a minute, what if we add another player to this, to the array of pointers? That is now currently on the stack, so we cannot expand that. We cannot call some function to change the size of that array, because it's on the stack, it's not on the heap. This is quite limiting for us. We want control to update both of those elements, and that is where true two-dimensional arrays come into play. Before we look at true dynamic two-dimensional arrays, I want to start off with an exercise here. We've already discussed that we can allocate arrays on the heap, and as I mentioned in the previous section, we want to move that array of pointers from the stack to the heap. So in this example, we can see that we allocate a new array on the heap, an array with 3 elements, and those elements are pointers to integers. Now I'd like you to think about this for a second. We need some sort of handle, some sort of variable to access that array on the heap. And I want you to think about what the type for that is going to be. Think about what the type is for the array on the heap, and then also think about what the type should be for whatever variable or handle we need that is on the stack, so that we can actually access and use those elements. I've blurred those out deliberately so you cannot see what is going on there. I want you to think about this for a second. Okay, moving on here, hopefully you gave that some thought. In a previous example, in a previous illustration, we had an array of integers on the heap. As I also mentioned, the pointer is basically going to store the address of the first element in the array object. Okay, so we assign the address of that first element in the array to a pointer. Of course, in the previous examples, we had pointers to variables, right? But in this example, we have an array of pointers to integers on the heap. Now, if you think back, what can we store the address of a pointer variable in? Well, we can store that in a pointer to a pointer, right? We cannot store that in a pointer. you store the address of a pointer variable in a pointer to a pointer. And for that reason, the handle, or in other words the variable that we'll have on the stack that we'll need to access the heap array, will be a pointer to an int in this case. That is going to store the address of the first pointer element in the array, which is now again on the heap. If you understand this bit, you are already halfway there. Now that we have that array of pointers on the heap, we can allocate arrays of integers in this example and store the address of those dynamic arrays of integers in the dynamic array of pointers. Okay, so this is a high-level example of what we can expect and what we can get from this. We have an array of pointers, and each one of those pointers can point to an array of integers, for example, which is also on the heap, and in this way we can create a true dynamic two-dimensional array. And as with the previous example, we can use the double subscript notation to access those elements which are now on the heap. Of course, we still need to think about allocation and deallocation, and typically we do this using for loops. As with the previous examples, this does not have to be a perfect table or anything like that. We can have arrays of integers of different sizes on the heap, and then we can have the pointer array point to those. As we can see in this example, now of course in this case the allocation is going to be a bit different because you're going to have to think about how you're going to do that allocation. Let's look at an example in Visual Studio. Again, I'm using the entity class for this example, so we can get the destructor printouts. And then in the main function, I have these are constants, row and columns. I set the rows to 2 and the columns to 3 here. Okay, so instead of using a pointer to an int, I'm going to use a pointer to an entity for this example. And I'm going to allocate a new array of pointers to entities on the heap. And I'm going to pass in rows for the construction of the size, so the amount of elements that is going to have. And I'll initialize the elements to null, because I'm going to use the empty list initialization. Now I'm using p here, but you can use something else, such as, we are basically going to create a table in this example. Now of course these numbers don't have to be even, but in this example we can now multiply those together to get the amount of elements that we actually have allocated in the arrays on the heap. So at this point we have our handle, this is a pointer to a pointer, and we have allocated the array of pointers on the heap. Now what we want to do is we want to allocate an array for every element that is in the array of pointers. For this example, we'll stick to arrays of entities of the same size. So I'll use a for loop. I'll use an integer here, and then you can stick to I, or what you can do is, it really depends on you and what you think is going to be easier for you to read. But for example, what you can do is, instead of using I, I'm changing that to current row. Okay, so we can see, okay, well, what row are we currently? We start off by initializing that to 0 because for every element in the array of pointers to entities on the heap now, we want to assign something to that, and of course we start at index 0, not at index 1. So as long as the current row is less than the number of, okay, so this is why I mentioned it's up to you how you want to write this. You can also use I for the iterator, and in this way this is going to be a bit shorter, but what we're going to do now is we fetch that handle, so we have the pointer to pointer. We pass in the current row within the subscript operator, and then we can allocate a new entity array. We pass in columns because we want the array of entities on the heap to have that many elements within it. Okay, again, if you think back to our example, we have the array of pointers on the heap, and every element in that array of pointers point to some array on the heap. So this is where we specify how many elements we want that to have. Now for every pointer element in the pointer array on the heap, we have an array of entities of this particular size, in this case 3. And what we want to do next is we want to go and actually change the values in those. I showed you this example where you can use current row, so over here you can use current row, current column if you want, but I'll just use I and J because that is very common to do that. Our entity class has these members, toString and setMember. Now we don't have to do the referencing here or anything like that. This will fetch the actual entity that is on the heap using this double subscript notation, and with that reference to the object we can do dot. To avoid 0 so that we can see we actually made changes to the member, I'll do 10 plus I plus j. So what we'll get with this will go to that particular element within the pointer array on the heap. And then we do another subscript on that, which will go to that particular element in the array of entities. Then we go and dereference this. So we can do dot setMember. And then of course you can go and print that out in a similar manner if you want. We will get a bunch of printers with the constructors and destructors. So in this case, I'll simply do this here. I'll do a toString on the final member. So we have 1 and 2. Remember, we have 2 rows and 3 columns. So I'll pass in 1 and 2 here. Now for an exercise, I'd like you to pause the video and go and do the deallocation by yourself. We want to deallocate not just the arrays of entities on the heap, but also the array of pointers. Both of those, of course, are now dynamically allocated on the heap. And before we build around this, we want to make sure to deallocate those. Okay, let's continue here. We have to think about what we want to do. We want to deallocate firstly the arrays of entities, and then we want to deallocate the array of pointers. In each iteration, what do we want to deallocate? We want to deallocate an array. So I do delete the subscript operator. We don't want to do this in the for loop. This is going to deallocate the array of pointers on the heap. We want to fetch the particular pointer in the array of pointers that this pp table is pointing at. Okay, so this is going to return that particular pointer, and then we deallocate the array that is pointing at. Then finally we'll do this delete here. We deallocate the array that this pointer to pointer is referencing. Okay, so if I build around this should work fine. We say we get those constructors. In the default constructor, we have a default argument of 0 again, so those are all initialized to 0. Then I do the toString right here. And then, so we get 13 there. And then we get the destructors invoked. And then end of program. So our deallocation works fine. So I know there's quite a bit going on here, but if you take your time and step through this, and maybe reference the illustrations, you'll see that this is not quite that difficult. We won't really use dynamic two-dimensional arrays all that much, but you may come across them in other people's code, and you may use them when you implement certain data structures and so on. So it is still an important topic to cover. Just scrolling up again, we allocate an array of pointers on the heap. Then for each element in that pointer array, we allocate an array of entities of this particular size. Then we just go and do some toString on that. We can set the members on that particular elements using the double subscript notation here. And then of course, once we are done with that, we want to make sure to deallocate properly.